Welcome back, everybody. So we got two binomials that I want to multiply together. Now, how do I know I want to use the FOIL method? What about the problem? What about the look of the problem tells me that I need to use the FOIL method? They're both binomials, right? Whenever you have a binomial times a binomial, which is a two-term times a two-term, you want to use the FOIL method. So, taking a look here, I've got x minus 3, x minus 6, both binomials. I want to use the FOIL method. 2x plus 1, 3x minus 5, both binomials. I got to use the FOIL method. So I'm going to write it out. Now, what is the FOIL method? Remember that it's just an acronym, just a fancy way to remind yourself how to use the distributive property with two binomials. F stands for first. O stands for outer. I stands for inner. L stands for last. First, outer, inner, last. First of the two binomials, the outer of the two binomials, the inner of the two binomials, the last of the two binomials. So let's write it all out here. We got our firsts, x times x. Now, be careful. I had a lot of people tell me this should be 2x. It's x to the second, folks. And a lot of people are forgetting the squared. And if you forget the squared, it's going to throw your final answer off because you're going to try to combine it with the middle terms. This is x squared. X squared. Outer, x times negative 6, so minus 6x. Inner, negative 3 times x, so minus 3x. Last, negative 3 times negative 6. Now, I've had a lot of people, as I was walking around, I see minus 9 sitting out there on the end. Minus 9. What did I do if I said minus 9? What was the error? I added, right? You have to multiply. Negative 6 and negative 3 make a positive 18 when I multiply them together. Be careful with that. And then I combine like terms in the middle. X squared minus 9x plus 18. There's my answer. All right, let's take a look at the second one. First, outer, inner, last. 2x times 3x. And again, I would encourage you to draw in all of these arches. I mean, if that helps you. If you don't need them, you don't need them. Okay, you're getting them right. Perfect. Good. You do you. 2x times 3x. And again, I've had a lot of people write this. 6x to the second, right? 6x squared, 6x to the second. Now we do our outers. 2x times negative 5 minus 10x. Now we do our inners. 1 times 3x, 3x. And when we do our laps, 1 times negative 5 is negative 5. I will tell you right now, the people that stay organized, the people that are nice and neat with their work, tend to do better on these sections. Okay? Try to stay very clean, very clear with your work. Okay? Questions about any of the problems on the warm-up? Okay, now I want to talk again about homework. I want to remind you that especially with this stuff, practice is key. If you're not practicing this stuff, if you're just copying the homework from somewhere, if you're just not really trying on the homework, if you're just not doing the homework, it's not going to the light bulb's not going to go on. You have to practice this stuff. A lot of this is just repetition on figuring out, okay, this is what I do with a monomial times a monomial every single time. This is what I do with the monomial times the trinomial every single time. Binomial times binomial every single time. It's all about repetition. You got to keep doing it over and over again so you learn the rules. Just so you know where we're headed. We have got section 7.2, day 2 today. Section 7.3 we will do tomorrow. Honestly, we're not really going to learn anything new tomorrow. It's just a couple of additional tricks with some of the same material, the multiplication stuff. Okay, that means on Monday we're going to review, and then on Tuesday of next week we have our quiz over sections 7.1 to 7.3. We just made it. It's again another 50-point quiz, another bigger quiz. And then again, you'll see that throughout this 9 weeks, bigger quizzes, less tests. Yeah.
So for the homework, because I'm just writing it down, what
Yep.
does it mean?
When you say you must write all work?
Yeah, how can you show that on an online assignment?
So here's what I want you to do. You'll notice that the back of the guided notes is blank. Here. Okay. So I want you to, just like I had you do on the homework last night, where I want you to write the original problem out, show the work, and then put it back in. That's what I want you to do on tonight's homework. So like, if you get to so say you're at problem number 2, you write down number 2, you write out the original problem, you do all the work on paper, and then you input your answer back into the computer. You might be saying to me, well, that's stupid. Why do I have to do that? Because I'm just going to show you the paper anyway. Yeah, you're going to show me the paper anyway, but that's how you have to do your end of course test. It's on the screen, and I tell you this, a huge issue that I have every single year is that kids look at the screen and they think, I can do that in my head, and I'm not going to write anything down. You can do this in your head? I mean, you must be better at math than I am, because I can't do this in my head. That's why I love when kids just like write answers down for these homework assignments. Like, no, because I can't do these in my head. Yeah, you've got to show the work, you've got to write it out, and I want you to practice that. I want you to practice looking at the screen, taking it onto the paper, doing the work on the paper, putting it back into the computer. Okay, that's what I want you to practice. Does that make sense? Does that answer your question?
Yes, thank you.
All right, let's go over at least one from 1 to 6, and then at least one from 25 to 30. Noah. Number 3. Okay, so we've got negative 4r squared plus 9r, times 9r plus 6. All right, so let's distribute in. And again, how do I know I want to use the distributive property? It's because that's a monomial times a binomial. Monomial times anything, I'm going to use the distributive property, unless it's monomial times monomial. Then I just multiply, like 1 and 2. All right, so let's distribute. Negative 4 times 9 is negative 36. R squared times r is r to the third. Remember, you're adding exponents there. R squared times r to the first is r to the third. And then I have a negative 4r squared times 6, so which is a minus 24r squared. And that's where we end. Are there any questions 1 through 6?
Yeah, I actually have 2 from 1 through 6.
Okay, go for it. What do you want to see?
Number 2.
Number 2. So here, this is another one where it's a monomial times a monomial. It's a mono times a mono. Now that means that I just multiply the numbers together, and then I multiply the letters together. Now, I've got d to the 4th, c to the 3rd. Do I have any like letters there? No, so you actually end up just writing it out. Somebody said to me earlier today, well, wait, that's not standard form. That's not the right answer. That's not standard form. You guys remember, standard form is when I have multiple terms going on. There's only one term there, so you can put it in any order you want because it's only one term, because it's a monomial. So therefore, I could have said negative 18, d to the 4th, c to the 3rd, just as well.
And then number 6.
Number 6. Okay, let's distribute here. Negative z squared times 2z to the 4th is a negative 2z to the add exponents 6. And we have a negative z times 10z squared, so negative 10 z to the 4th, add exponents. Negative z squared times a negative 16. Oh, all right, so the only thing that combines here is a negative and a negative makes a positive. And then I just have to carry through everything else. Does that make sense? Questions? All right, let's go over at least one from 25 to 30. At least one. Yeah, Brianna?
Number 28.
28? Okay, let's take 28. Oops, that's not the right thing. All right, so again, I want to FOIL this, and I see that because it's a binomial times a binomial. 5g times g is a 5g squared. 5g times 8 is a plus 40g. 3 times g is a plus 3g. 3 times 8 is a 24. Not 11, 24. So I have a 5g squared plus 43g plus 24. That make sense? Any other ones that we need to go over 25 to 30? Yeah.
Why wouldn't you add the 5g to the 43? Is it because 5g squared?
Yes. Yeah, because it's not like terms technically, because it's a different power. Any other questions on the homework? Okay, again, practice makes perfect with that. If you're not doing it, the homework, it's not going to click. All right, so again, more of the same today. Okay, more of the same. We're just going to keep moving forward with our polynomials. You know, yesterday we learned multiplication of monomial times a monomial, monomial times a binomial, mono times a trinomial, and then we graduated to binomial times a binomial. And that's where we stopped. We stopped with binomial times a binomial. So where we're going to pick up today, we're going to take a binomial times a trinomial. Actually, you know what? This first example, it's a binomial times a binomial. So why don't you go ahead and just do that problem right now? You guys could just start on example A. Because you should know how to do that now. Everybody do example A. Yeah.
Today, February 10th.
Yeah. All right, let's take a look at this one. Multiply binomial times a binomial. Again, I want to use the FOIL method. FOIL method. And guys, again, well, I'll talk about that after. So I've got 2x times 3x. Firsts, right? 2x times 3x is a 6x squared. Again, watch out. I see a lot of people just writing 6x. It is 6x squared. Outer, 2x times 7. 14x. Inner, negative 4 times 3x. Negative 12x. Negative 4 times 7. Negative 28. And then I combine like terms on the inside. And again, be careful. I want to add here. I want to combine those like terms. So 6x squared plus 2x minus 28. Is that what you guys got? How did we do on that? Did we do okay on that? Hopefully this is starting to click a little bit. Hopefully those binomials times the binomials are starting to click a little bit. Now, why am I doing this problem right off the bat? We learned this yesterday, right? Well, it's good to review, but also think about this. I talked to you guys about the FOIL method yesterday, but in essence, isn't just the FOIL method just the distributive property?
Yes.
It's really just the distributive property. If you wanted to forget about the acronym of FOIL from here on out, you could, because it's just the distributive property. Like, think about it. Watch all these markings that I have here. If I wanted to do the firsts, that's 2x times 3x. If I wanted to do the outers, that's 2x times 7. If I want to do the inners, that's negative 4 times 3x. And then my last is negative 4 times 7. That's just the distributive property, right? It's just a catchy way to remember to do each piece. It's not like I made up some new type of multiplication. It's just a tricky way to remember how and in which order to multiply. Yeah.
So Well, I like doing that better because it's like more clear. Because that thing,
The distributive property?
the FOIL thing is just ugly and confusing.
That's fine. You do you. Okay. So, but the thing is, it's the same thing essentially, right?
Like you won't take off points.
Right. You're doing the exact same math. So it's not any different in terms of like writing out the terms each time. It's the exact same thing. Yeah.
I don't really use the rainbows. I can just kind of like just do them and like.
You be careful with that, Gio.
Yeah, but like.
You be careful.
What is that supposed to mean?
I'm just saying, watch out. Sometimes if you don't connect it like visually like that, you might miss a term here.
Like a WWE announcer. Watch out.
You. Here's what I mean by that, is when we have more terms like this is a binomial times a trinomial. If you're not drawing the arrows in, or the rainbows as you like to say, if you're not drawing those in, then you might miss something along the way. Okay? So here, let's take a look at this one. This leads me to my next problem here. Is this a binomial times a binomial anymore? No. So like the whole FOIL acronym goes out the window anyway, because this is now a binomial times a trinomial, which essentially just means, okay, well then just distribute again. So this is what I have to do. I need to take an x times an x squared, an x times a 4x, and then the x times the negative 6. So let's do that. X times x squared. What's that?
X third.
The third. Start far to the left, because there's going to be like 6 or 7 terms. X times 4x. 4x squared. X times negative 6. Negative 6x. So that's just the x distributed in. Now let's take the negative 5 in. Negative 5 times x squared. Negative 5x squared. Nothing to combine or to do, just to put it together. Negative 5 times 4x. Minus 20x. Negative 5 times negative 6. Positive 30. Watch out. Make sure you write it as a positive 30. Negative times a negative is a positive. And now I combine like terms just as I had using the FOIL method. But in this case, I've got a couple different like terms. Now, is there any like terms to the x to the third? No. So that just gets carried through. I've got a 4x squared and minus a 5x squared. Okay, so negative 1x squared. Or just negative x squared. Worked with those. And then I've got a negative 6x and a negative 20x. Okay, negative 26x. And then I can just drop down my plus 30. Nothing to combine there. And that's my answer.
So they just take longer. They're not hard.
Right. It's still the same process, still the same stuff we did yesterday, still the same distributive property, but now we're just doing more of them, right? Just more things to distribute. And honestly, that's the rule for any polynomial times any polynomial. You want to do a 4 term times a 4 term? You just got to do the distributive property basically 4 times over. Okay? I won't give you anything that in depth, but essentially that's how you would do it. Yeah. Let's take a look at the next one. 2x minus 5 times negative 4x squared minus 10x plus 3. All right. So let's distribute in. 2x times negative 4x squared. All right, so negative 8. 2 times negative 4 is negative 8. X to the third. Excuse me, to the third. 2x times negative 10x. Well, 2 times negative 10 is a negative 20. X times x is an x squared. Be careful with your powers here, folks. If I had to pick out one mistake that I kept seeing all day, yesterday, and checking the homework today, you guys miss out on the powers, especially here, because now we're going to get higher powers. 2x times 3, 6x. And now we bring in the negative 5. Negative 5 times negative 4x squared is a positive 20x squared. Negative 5 times a negative 10x is a positive 50x. And then a negative 5 times a positive 3 is a minus 15. What's that?
Negative 5 plus 3. Wouldn't that be negative 2?
Watch out. Times. It's not plus, it's times. And now we combine like terms. We drop down the negative 8x to the third. Look what happens with our x squareds. They cancel. And then 6 and 50 make 56. And then we drop down our minus 15. That one only had 3 terms, but that's the only reason is because the x squareds cancel, and that was just a coincidence. Questions about that? Yeah.
So on the last question, did you go to like the last?
Yep.
I don't know, because like we had the 20, the negative 20x, and then we had the negative 6x, but then like we like added them.
Right. Well, it was negative 6 and negative 20.
Yeah, but then on the next one, we had negative 20 and negative 20, and we canceled them out.
Well, no, we had negative 20 and positive 20.
I had negative 20.
Watch out, and I think this is the reason. This one should have been a negative 5 times a negative 4. Negative times a negative should have been a positive 20x squared. Okay, let's take a look at our last one. Now, this one's just going to be a little weird, and the reason being is because the binomial is out of order. I mean, if you wanted to put it in order right now and then multiply in, sure, that would be fine. But I'll do it as is. Let's see what happens. Let's distribute the 2. 2 times 3w squared, 6w squared. 2 times w is 2w. 2 times negative 1 is negative 2. And then I'm going to distribute in the negative w. Watch out. Again, this is a negative w. Negative w times 3w squared is a negative 3w to the third. Watch out. W times w squared is w to the third. Negative w times positive w. That does not cancel. That does not cancel. Negative w times positive w is a negative w squared. It does not cancel. I'm multiplying, not adding. Negative w times negative 1, negative and a negative make a positive w. Now, everything is misordered here. Everything is all out of place. So you've got to put it in place. The first term that should come down is a negative 3w to the third. I'm going to cross them out as I go to make sure that I've got everything accounted for. And then I look for my x squareds. Okay, I've got a 6wx squared minus 1w squared.
5w squared.
5w squared. I've got a 2w plus 1w, 3w. And then we bring down our minus 2. And everything's accounted for. Yes?
On that test, is it okay that we scribble the things out?
Scribble the things out.
I'll explain after you do.
Okay. Hi, Mrs. Colella.
Nick, I think we'll be okay if you scribble the term.
Yes.
That's what I thought.
Yep. Bye.
I will have credit.
What were you saying? The things? You
Yeah,
scribble
so
the things.
You know how you crossed out the 6w and 2w?
Like this?
Yeah. On the test, are we allowed to do that?
Yeah, I would. Here's the deal. If your answer's wrong, I'll look at your work.
Yeah, that's what I was saying.
You know, if I can't see the work, then get a little dicey. But
Okay.
yeah, a little risky.
Yeah, you got it.
I'll lightly shade it
There you go. Or just make it through.
like a cross.
Yeah.
Okay.
I'll cross. I'll like check mark it.
Okay. Okay.
Yeah, that's good.
All right. I'm going to give you the rest of the time to work on your homework. Again, I left the back of the guided notes intentionally blank. If you'd like to put your work on there, if you like lined paper, that's fine too. But I want everybody working on this online assignment right now. Okay? You get 3 checks per problem again. Watch out. it's marking answers wrong if you're not putting them into standard form. There's a couple right off the bat that last period kids were getting frustrated with because they're like, this is right, I've checked it, this is right. But it's saying it's wrong. What did I do? You've got to put it into standard form.